Hello everyone and welcome back. In this video tutorial, I'm going to talk about the way that the MIPS architecture stores data in the memory. As you know, we can declare data with different sizes. In MIPS architecture, you can declare 1 by 2 bytes or 4 bytes data. But in all of the cases, there is a special alignment restrictions. It means that the start rest of the data should be a multiple of the data size. For example, if you declare a date of it for bytes or if word there is not a trace of the word should be multiply of 4. Or if you want to declare a date with size 2 bytes or half for your data to start, this should be a multiply of 2. Of course, for the 1 byte data there isn't any restriction because every memory location is a multiple of number 1. Let me give you an example. Assume that each square in the table shown below represent 1 byte in memory and each row stores 8 bytes in memory. So this is the memory map of 32 bytes. This is the start of the first row, and the artists of each square can be found by the addition of these numbers with the start address. So this is artist 0, 1, 2, 3, 4, 5, 6, 7, and this is 89A, B, C, D, E, F, and after that it will be 10 in the hexadecimal. Starting at 0100100000 in hex. In the data segment, show the byte content in memory in hexadecimal for the following data definitions. If a byte is not used or initialized, then leave it empty. Fill only the bytes that are initialized for words and half for the Little Indian byte ordering should be used. As you remember, there are two ways to store data with size of half or words in the computer. Little Indian or Big Indian by default. The MIPS architecture uses a Little Indian idea. So when you have a 4 bytes data, first the low byte will be stored and then the second byte from the right side. And finally, in the last location, the leftmost byte will be stored. Let's see. In this example here, we use directive.word to declare one word data and its value is -2. So as you know, -2 can be represented in TOS complement as FP if you want to represent it as 1 byte. Let me show you here. So 0xf is -2, but this is the representation of -2 as 1 byte. If you want to extend it into 2 bytes, then we will use the sign extension method. So since the sign bit here is 1, then we will put 81 in the left side in order to extend this 1 byte into 2 bytes. And we want to represent it as a hedge. it will be F, 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 T. This is the 16-bit, 16 bits representation of -2. So by the same way, if you want to represent -2 into 32 bits, we will use F, F, F. If. So this is 16 bits, one that I added in the left side of the previous data that I have in order to extend it into 32 bits. So now I'm going to store this data in this 4 bytes of the memory. So the start address of the data should be multiply of 4, and you can see that this data, this is start out, this is the multiply of 4, so I can save it here, and since we use the little Indian method, so first the low byte will be stored. So here, it will be a store. And then, the next flight we have if second by 30 time and before. So this is the way that -2 will be stored in the memory with the start address of 100100000 in the hexadecimal. It takes 4 bytes and the data is stored from the left side. If E, then the next F, this to FF will be here. And finally, this part will be in this location. So we declare the first data in the memory. Now, in the next line, we have a data with half size or 16 bits data, and its contents is 1F, F, F. So for data with size 2 bytes, the start of this should be multiply of 2. Can I stop it here? Yes, it is an even number and it fills the address, which is the multiply of 2. So the data again is stored as the little India. So first F will be here and then 1F in the next location. FF will be here and here. 1 of. The next line are used that align assembler directive. It means that we want to add a new restriction. For the next data that I declare, the start address should be multiply of 2 power to multiply of the 2 to this number. And I used 2 here. So 2 power 2 is 4. So the next data should be declared in a location which is a multiply of 4. So can I install it here? No, because this number is not multiply of 4 and also this one. So I should keep them empty. And this is the first location that can be used. So the next data that I declared as byte will be stored in this address, because we use that align to here with the color 2 bytes with value or initialize value 11. So each one takes one location or one square. So I'm going to display everything in the hexadecimal I use. 0x 0p. This is the second part, and so the column operator means that repeat this value 3 times. Now I use again the alignment assembler directive, and this time we pass number 4 here. So the next location that I want to use should be multiply of 16 to power 4. So of course this is not a power of 16, and also this is not a multiple of 16. And this one, this is the first location can satisfy this condition. Every hexadecimal which is multiplied of 16 will be a start by 0 in the rightmost. So this is the address that I can use. I have two data and both of them are bytes 13 and -1. So 13 again can be represented as 0x 0. C. Currently. And my next one is FF in the hexadecimal. So this is the content of the memory after we declare this data. And I keep empty the locations that are not used. Some of them are not used because we use that align and use this restriction, and some of them are not used because the startup is of the variable should be multiple of the size of the variable.